Okay, so v of x was 4x cubed minus 60x squared plus 216x. V prime of x equals 12x squared minus 120x plus 216. 0 equals 12x squared minus 120x plus 216. When I divide that by 12, I get 0 equals x squared minus 10x plus 18. X is equal to 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 18 all over 2 times 1, which is 10 plus or minus the square root of 100. 8 times 4 is 32. 72.
Mr. Hale or Mr. Frank, could you call extension 3003, Mr. Hale or Mr. Frank, call 3003.
What was the answer? 2.35 and 7.65? Okay. That's me doing that at 100 miles an hour. If it took you longer than that, that's okay, don't worry. All right. I also simplified the radical in this step here, which is sometimes useful. Okay, so I took out, divided it by 4, because 4 squared, and then that turned into 2 outside the bracket, 2 outside the root. Okay, what do those two things mean in English? Private Bishop, what do those two things mean in English? Not really the intercepts. They're the point, this is we're talking about the slope, right? So it's sort of like intercepts, but the intercepts are slope. Help me out there, Jared?
V of x.
Right on. So just so, I don't know if you heard that, to make sure this is where the slope is going to be 0. So that it's not going to be increasing or decreasing. What can I do with 7.65? I'm going to just make it disappear. Why do I make 7.65 disappear? Greater than my domain, so this one's out. Okay. So I'm going to make my chart. And say 0 is less than x is less than 2.35. And then 2.35 is less than x is less than 6. I'm allowed to do that because my domain was just 0 to 6, right? All right. My original function, what was it? Ugh. I don't really have anything to do there, do I? So like test. And overall. So this is x squared minus 10x plus 18. Okay, now notice that sort of scrunched in there, but I couldn't, there was nothing I could do to that. It's not in a factored form. So I had to just use the entire f prime of that function. Okay?
Should we just use overall?
Yeah, you can do overall. You can get rid of that if you need to. I'm just going to pick a test point here and try it out as 1 and 4. Okay, so 1 minus 10 is minus 9 plus 18 is a plus, so that makes that a plus, which means it's going to be increasing. 4 squared is 16 minus 40 is negative 24 plus 18 is a negative. Therefore, increasing up to 2.35 centimeters cut. Therefore, at 2.35 centimeters, we have maximum volume. Okay? That makes sense how I got that? Sort of. One nod. Thank you, Nathan, for nodding. Hope that wasn't just a twitch. I hope that was a nod. Okay, it is. Okay, good. So we're sort of okay. Austin, your hair's looking fine as usual, if you don't mind me saying. It is. Why do you guys laugh? You have a nice looking hair. As in guys in grass. Brendan, yours is sticking out more than usual today, so. It is. Look at it. that's enough jokes for one day. Just one last joke and then I'll continue here, okay? This is, you know that Yoda man joke I told yesterday? I actually told it wrong. It was supposed to be knock knock. You said Yoda. Yoda best. That's what it was supposed to be, right? So, it's still. Alright, example 3. No more bad jokes.
We should have told that us tomorrow.
Yeah, you haven't forgotten all about it then. I could have told you the same joke 100 times and okay, this is going to be our last example today. Example 3 says, that's not the right time. What, please?
10.
10 o'clock, 10.
Well, that's true. Actually, 10.
Number 3 says a piece of wire is bent, that's right, is to be cut into 2 pieces.
It's not even that, I just can't visualize it. It didn't make any sense.
Okay. Now, the neat thing about this question is that it doesn't tell you how long the wire is. This is what makes calculus magical. So it's 8 minus x squared, something like that. Okay, the wire could actually say a of x only. That means it's horrible, so I throw that. Look. Okay, part A. Actually, we're just going to say this. Determine the intervals of increase and decrease. And sketch the graph. Okay. Please put a star and a heart beside this question. Now, first of all, you guys can do this. 8 minus x squared, that's what's, I can rewrite that for you, Bailey. Because what happened was I forgot to write the square initially. Okay. 8 minus x squared. Now, this is a star and a heart question. This looks awful to graph. Would you agree? It does, because there's a 1 over 4 pi, like it's a mess. So this is actually a real equation for if you're to do this. What I'm saying is this. I have a piece of wire, which I'll call, this is my piece of wire. I'm going to bend it so that it looks like this. Okay, that's how I'm going to bend it. So the start of the wire is going to be here. You're going to bend it around sort of like this. And you're going to go like this. That's what it's going to look like. Okay? So it is possible. Yes, with my hands. So you're going to slant the wire like this. You're going to bend it into a circle so it looks like this. Then you're going to do a square like this on the other side. Okay. All right. Good. Good enough. It's not like that time when we were doing the unit circle and you guys make me spin around 20 times until it fall over. That's not nice. Okay. So don't do that.
But why would you? Why would you put a wire in a circle?
Because math demands it of you, of course. All right, f prime of x equals. Now, first of all, have confidence in yourselves. You can do this derivative very, very easily. Who have I not picked on yet today? Tanner Pryor. What's the derivative of 1 over 4 pi times x squared?
2 bracket 1 over 4 pi x.
Yeah. I'm just going to call that 2 over, if that's okay, which is 1 over 2. Okay, so I'm just going to call it that, and I'll end up calling that 1 over 2 pi x. Okay. Now for the next one. Noah Solinger. There are also master derivatives. What is 1 over 16 bracket 8 minus x squared equals to? Please the derivative of that. Oh, don't put yourself down. Pretend the 1 over 16 wasn't there, because you can just ignore it. What is 8 minus 1 x squared? What's the root of that going to be?
Negative 2x.
Negative 2x. So it's just going to be plus 1 over 16. Negative 2x. Okay? Everyone sort of see how that went, hopefully? So that then turns into negative 1/8 x. I'm also going to do a little trick here, because I'm tricky. What the heaven did I just do there? I just factored an x, okay? Which is going to make this look a lot nicer, okay? So, yes.
Can you also factor out 1 over 2?
You totally could if you wanted to, but this is just easier to deal with for the x.
Okay.
Okay, because remember we're looking for just when it's positive, when it's negative. That's all we're looking for here. Okay. So, let's do our intervals now. We're going to have an x is all we have, x bracket 1 over 2 pi minus 1/8. Test overall. When is f of x equal to, when is f prime of x equal to 0 here? Sorry. When is f prime of x equal to 0?
When x equals 0?
X equals 0. So we're going to have x is less than 0. And we're going to have x is greater than 0.
Let's see.
So, negative 1, we're going to use negative 1 times that. Now, here's the thing. Is 1 over... Oh, just going back to here. How do you make this entire function 0? The only way for it to be is x of equals 0 is your only solution. Okay, is 1 over 2 pi minus 1/8, is that positive or negative? It's positive? I trust you. 2 times pi is 6.28, so that would be positive. So a negative 1 would be a negative value. This is going to be a positive value. Overall is going to be negative, so it's going to look like this. This is going to look like this. Now, to graph officially,
That name was like 5 years ago. It's so old.
okay, so we already know what our turning point, like what the turning points are. Okay, I'm going to call it a local max or local min, and finding f of that to find exactly where it's going to be. All right, so our original function was, let me find it, a mess. So f of 0 equals 0 plus 1 over 16, 8 minus 0, which is f of 0 equals 1/2. Does everyone follow what happened there, hopefully? Really, I thought all you told me was that you wanted me to go faster and faster and faster.
Yeah, that
of
was
course.
the page is over, but I have to wait for the
You're saying my hair is getting in the way of
Yes.
your learning?
That's what I would say.
Your luscious hair.
Yeah. You know, okay, I never pause and tell this joke because it was so offensive. My brother gets a kick out of it every time I tell him. So I'll really write this down. Okay, so as far as, yeah, I know. So as far as how this graph is gonna go, this is just gonna be we'll do a rough sketch again here, because I wanna finish today's lesson. If I can, we're gonna run through them. So here's my graph. In calculus, we're not going to worry much about zeros. Okay, so what did my interval chart say? What happens on the left of 0? We are decreasing. So it's going to look something like this.
Is that a fall or is that an intercept?
That's an intercept. Okay. What's going to happen on the right? Sorry. What's going to happen on the right of 0? Increase. Now, does it make sense the graph looks sort of like that? Does it make sense that the graph looks like that? Well, it totally does. What's my equation? It was a quadratic. Does it make sense that we have a quadratic? Well, yeah, it does. That's a parabola. I'm just using calculus just to show these things today. How are you feeling about the world? I just want to say I appreciate your volunteering. Just say that makes me very happy. All right, homework. Now, what you will notice here, even though this unit is called graphing, it's also there'll be optimization problems. So there will be a lot of word problems in this unit as well too. So get yourself accustomed to doing them. Okay. People, I know you guys are calculoids, so it shouldn't affect you guys, but word problems tend to sometimes make people cause people to freeze and get afraid. I think most people yesterday aced the word problem on the test. Okay, the one with the Sadler's book. Sorry, for those that read it. I shouldn't say what it was. Okay, but that type of word problem shouldn't be an issue, right? So just get in the habit of doing the word problems. Most of these are going to be word problems tonight. Okay, so and if there's any that you need me to go through for tomorrow, I can do so. I'm not going to do it done. I'm going to mark your test tonight or get most of them done, and we'll see what we do. So.